So, okay, so we talked a little bit about motivation last time, or quite a bit about motivation. And what I told you that I was basically teaching you a personality neuroscience approach to personality. And part of the reason that I have to go into the biology is to give you the kind of foundation that you need in order to understand, I would say, what's essentially the cutting edge in personality research. You know, I mean, I know that what we covered last lecture and what we're going to cover today are relatively complicated, but if you get them right, then you're right at the forefront of our ideas about brain function and emotion and about personality. So you get all that at the same time, and today you'll get a little bit of learning theory thrown in as well. So learning theory is basically what used to be what's alternatively described as behaviorism. And I used to teach behaviorism in this class, but I've subsumed it underneath the biology because a lot of the old behavioral presuppositions, although they were extremely useful, were not right, which is exactly what you'd expect. They were formulated in the 1950s. And it's actually the sign of the progress of a science that theories that are 60 years old are no longer right. So we'll also cover a little bit of behavioral theory today too. So, okay, so the hypothesis we've been working on so far, or we'll call it the working theory, is that motivations set goals, or more accurately, that they define a conceptual space within which you perceive the world and within which you act towards some goal or to some endpoint. And the endpoint, in some sense, is specified by the motivational system. It's a hypothalamic system often, but not always. But not only is the goal specified, but the underlying motivational systems also tune your perception, so you're only looking at the things that you know to be relevant to the pursuit of that goal. And they also either disinhibit or activate the behavioral schemes that you would normally use to pursue the goal. And sometimes those, or let's say the motor schemes, because that would be more accurate. When you think about behavior, you tend to think about voluntary behavior, but a motivational state will disinhibit or activate, depending on the situation, autonomic responses. So for example, when you're food deprived and you start to think about food and start to organize your behavior towards food as an end and to perceive the world that way, your body also prepares for food. And so the motivational state is an all-encompassing psychophysiological phenomena. It's not something as simple as chain behavior, which was an early behavioral theory, or as simple as something that's merely setting a goal. It's much more complicated than that. It's useful to think about, as we've already talked about with regards to psychodynamic theory, it's useful to think about a motivated state as a micro-personality. I mean, it's got one aim in mind fundamentally, so it's not particularly sophisticated, but it has all the other elements of a personality. So motivation establishes the framework within which goals are pursued and the goal itself. And then, roughly speaking, emotions, or at least many of the emotions, track progress towards goals. And so they kind of tell you whether you're on the right track or not. So that's a reasonable way of distinguishing them, even though there is no single motivation system or single emotion system. Here's some basic motivations. These are the sorts of things that Freud would have associated fundamentally with the id. So, and he thought of those as primordial, and that's exactly right, because pretty much all of these motivational systems we share, certainly with other people, also with other mammals, and then, of course, with animals that are farther down the evolutionary chain than mammals. So some of these systems are extraordinarily old. In fact, all of them are extraordinarily old. Hunger, consequence of food deprivation, obviously. Thirst, obviously. People are very dependent on water. Pain. Pain's complicated. There's physical pain, and then there's its mental equivalents. And the mental equivalents of pain are grief, disappointment, frustration, roughly speaking. And so the way you can think about that is, you saw the picture of the nervous system that I showed you last time with the branches going up into the brain, obviously, but with all the branches, or the roots, say, going down into the body. So we discussed the central nervous system as a sort of all-encompassing system distributed throughout the body. Imagine that part of that network throughout your body is associated with pain reception, and that would be roughly equivalent to systems registering levels of input that are high enough to potentially damage them. That's where pain seems to come in. And that different pieces of that can be activated at different times. So if it's psychological pain, as I said, grief, frustration, disappointment seems to fall into that category. Loneliness is another one. Then maybe it's primarily the cortical circuitry for pain that's activated. And although people who are depressed, for example, or who are grieving, often have somatic pain as well. And depression really looks like it's a pain state. We know loneliness is because if you take like little chicks or little kittens and you make them lonesome and they'll cry, you know, which is or peep if they're chicks, and you can stop them from doing that by using opiates. And it's not because it stops them from vocalizing, because that would be a possibility. You just get them so stoned on, you know, morphine that they can't peep, and you think, well, they're not lonesome anymore. So the experiments have been done carefully enough to factor out the effect of the opiates on the vocalization. So, and that's also led to some suspicion that people who have had a history of extraordinarily painful personal relationships might be those who are more prone to opiate use. And so opiates, analgesics, they basically dampen out pain and frustration and disappointment and grief and loneliness. So there's an anger and aggression system. It's complicated. There's probably two of them. One is defensive aggression. That's probably more associated with neuroticism, technically. The other is probably predatory aggression. And, you know, human beings are definitely predators. We're meat eaters, and, you know, our closest relatives, chimpanzees, for example, they're pretty good hunters. They'll gather together in packs and bring down 30-pound colobus monkeys, and the meat is very popular among the chimps. And so predatory aggression seems to be a separate circuit, and as we'll discuss further along, I think the predatory aggression circuit and the maternal solicitude circuit, because there's also a care circuit, have evolved to be at opposite ends of the same distribution. I think that's the agreeableness distribution in the big five. So on one end there's maternal solicitude, and the other end there's predatory aggression. And you can imagine how those things have to inhibit one another. Because, well, with many mammals, bears for example, the males are so predatory that you have to keep them away from the cubs because they'll kill them. Human beings, I mean, there's some aggression towards children, especially if the children aren't biological relatives, but men are pretty caring for male mammals, and women are actually quite predatory for male mammals. So thermoregulation, your hypothalamus takes care of whether you're hot or cold. Panic and escape, those are circuits that also seem to be associated with pain fundamentally, although threat can maybe trigger them as well. And the panic escape system doesn't exactly seem to be the same system as the anxiety and fear system, even though they sound roughly equivalent, right? You might think of panic as just the extreme level of fear, and I think fear can trigger panic, but panic seems to be a more primordial circuit, and if you're panicking, there's an immense impetus to escape. So that's a different circuit. Affiliation and care we covered, sexual desire. Exploration and play, both of those seem to be separate circuits. So Jack Panksepp actually, who wrote a great book called Affective Neuroscience, by the way, if any of you are interested in like the psychobiology of behavior and motivation, Jack Panksepp's book is one of the best. I don't have a paper by him in our collection, but he's a very smart guy. He wrote this book called Affective Neuroscience, and it's actually, given its title and the relative complexity of its thoughts, it's actually quite readable, even though it's a text. It's a little more personal than your typical text might be. And Panksepp is also very interested in psychodynamic and personality ideas, so he's a very broad thinker. And so if you're interested in an approach to psychology that sort of crosses the threshold from personality into emotion and biology, Panksepp, as well as Gray, there's a Gray paper that you're reading, Panksepp's a very, very good source. He discovered the play circuit, for example, and he also discovered that rats laugh. So if you tickle a rat, it laughs. You can't hear it though, because it laughs ultrasonically like a bat. But if you record the rat giggling and then slow down the tape, then you can tell that the rat laughs. And rats need to play, and most mammals need to play in order to socialize them. So one of the things, you can think about this when you're parents too, and this is probably especially relevant for the men, because one of the things you might ask is, what role do men play in the socialization of children? And one thing that men really do seem to do with kids is to engage in rough and tumble play, especially once they're a little older than 2, say 2 to 5 or something. And kids love that. They absolutely love rough and tumble play. Gets them so excited that, you know, they get out of control fundamentally. But rough and tumble play is an excellent mode of socialization, because it teaches the child the distinction between aggression and too much aggression, right? Because if you're wrestling with a kid, the kid has to keep their behavioral output under a fair degree of control to keep the game going, to make it rough enough to be exciting, but not so rough that they get hurt, or, you know, that they stick their thumb in their dad's eye or something like that. And you can think of that from a Piagetian sense too, because it's a game. But imagine that if you're trying to figure out how to configure yourself around other people, if you haven't had that rough and tumble play, you don't really know where the boundaries of your body are, you know, and you don't know how much you can take and how much you can be stretched and how much you can be thrown around, and when something actually hurts rather than is frightening. And so all of that intense sort of play that boys in particular are likely to engage in, although girls also like it, seems to be very useful for teaching children about how to engage with the world and with other people in a physical way. And that's one of the physiological foundations for higher order socialization. So it's very useful. I mean, I've often noted that children who haven't had the opportunity to engage in physical play, they're kind of awkward. You know, they're not seated well in their body, and it's like they're kind of vague physically. Whereas the ones who've been twisted around and bent and thrown up in the air and, you know, wrestled in general, they're a lot more conscious of their limits and their abilities in their body. And they're also much more able to invite other kids to play. You can think about this with regards to dogs. You know, if you have a dog, you know, the dog, you can tell when the dog wants to play, right? What does the dog do? Yeah, it jumps around, and it puts its rear end in the air often, and its head down, and it looks up, which is a little bit submissive and a little bit friendly, and it wags its tail, and it might bark, and it moves back and forth. And like little kids that want to play do, well, they don't put their tails in the air, obviously, but they engage in like play invitation behaviors like that, you know, a little bit of teasing sometimes, and they're trying to get some play initiated. It's also practice for later dominance. When chimps play, the males in particular, as they approach adolescence, the play behavior, because they'll throw sticks at the old chimps who are laying down and sleeping, or come up and poke them, or, you know, tease them. And then as they become more and more powerful and more adolescent, say into adulthood, then that play will become full-blown dominance challenges, as you no doubt noticed if you were in junior high school, because that's exactly what happens to teachers, right? The little elementary school kids, they're kind of cute. When they misbehave, they're sort of playful, but by the time grade 8 or grade 9 comes around, the pushing on the teacher is a lot harder. And so you can see how play shades into dominance dispute. But it is a separate circuit. Exploration, that's a separate circuit. And one of the things that we'll talk about today is Swanson's elaboration of the fact that half of the hypothalamus is fundamentally devoted towards exploration, which is quite cool. It means exploration is a really, really, really old system. And it's sort of like, if you haven't got anything else to do, so you don't want to play, you're not hungry, you're not thirsty, you're not angry, you're not too warm or too cold, etc., etc., your default isn't sort of quiescent sleep, right? You don't just run out of batteries and lie on the floor, unless you're, of course, obviously, unless you're very tired. What'll generally happen is if the other fundamental motivational states have been satiated, then you'll engage in exploration, and some different people at different rates. If you're extroverted, you'll engage in exploration in the social environment, and if you're open, then you'll engage in exploration at a more cognitive level. So that would be with regards to artistic creativity, or to fiction, or the expression of some sort of intellectual or philosophical pursuit. And the reason that you're wired up that way is because if you have a little extra energy, you might as well use that to map out more of the environment, so that when push comes to shove somewhere down the road, you'll be in possession of more information and more flexible and more knowledgeable in your conceptual and perceptual structures, and also in your actions. So people have a pretty strong tendency to default to exploration, but there's variability in that. You can also sort of divide up these motivations as ingestive or defensive. That's not a bad way of looking at it. And then there's reproductive motivations as well. That's unlikely to be a full map. It kind of depends on where you put the emotions, because we know, for example, that there's a separate disgust circuit, and that doesn't seem to load with anxiety or with pain. It's its own biological system, and it seems to be associated with trait conscientiousness, maybe, and also with political conservatism and orderliness. So those things are all quite interesting. They all kind of clump together. But whether that's an emotion or a motivation's not exactly clear, but we'll talk about it a little bit more. So there's the hypothalamus, and as you can see, it's not one thing. Of course, nothing at the macro level in the brain is one thing, obviously. It's this layered thing, just like everything else in the world, except even more so, because the brain is so incredibly complicated. And you can see by looking at that, there's all those little, all the things that are colored there are basically hypothalamic modules, I guess would be a reasonable way of putting it. And you can tell they're even anatomically distinct, so obviously they're not doing exactly the same thing. So you might think of brain anatomy as sort of a fixed, what would you call, something that we've already managed quite well, and we have all the category systems down, and the structure of the brain's quite well known, and that's really not true at all. Like, the brain is truly terra incognita, and it isn't even, like, our naming rituals, let's say, or conventions are not necessarily appropriate for one-to-one mapping of, say, structure onto function. So they're sort of anatomical. They're markers for anatomical convenience in some ways. Okay, so here's a way of thinking about it. So you have your frame, which specifies your lack. Say, I'm hungry, and then a goal pops up, which is, well, I should have something to eat. And the hypothalamus is modulating perceptual and cognitive circuits so that you think that, and so that you start to parse up the world into a place where a hungry person like you could become satisfied. And then the behaviors kick in that are relevant to that pursuit. And so you can think of yourself as popping through these sorts of frames on a fairly cyclic basis throughout the day. You know, obviously, you get hungry, you get thirsty, you get tired, and so your consciousness is being modulated by subcortical circuitry that is basically charged with your self-preservation, and in some ways you come along for the ride. I mean, your consciousness is mostly there, in some sense, to detect deviations from not so much expectation, but from desire, right? Because you lay out one of these little maps on the world, and then you want something to happen. And what your consciousness does, more or less, is monitor, and if something that you don't want to happen happens, then consciousness will take a look, in some sense. You remember that hierarchy of goals that I showed you, from, you know, motor output up to high order goals? Your consciousness kind of moves up and down that thing if you've made an error, trying to figure out at which level of abstraction that error should be rectified, which is sort of what you do when you think. And so that process is going to kick in whenever you're moving towards your desired end, and something that you don't want to have happen happens, right? You usually stop. That's sort of an anxiety response, the stopping. And then if nothing else happens that's too bad, well, then you'll start to explore. And animals often do that by moving around, but people will do that just as with equal facility, just by running simulations in their mind and trying to calculate what went wrong, right? Trying to think about it. That's a form of exploratory behavior as well that would be more associated with trait openness and with intelligence. So there's how Swanson divides up the hypothalamus. See the little pink things there on the left are part of the defensive circuits, and then the red things on the left are part of the reproductive circuits. And, you know, obviously those the fact that those circuits exist lays onto Darwinian theory quite nicely. The defensive circuits obviously protect you from dying, and the reproductive circuits, facilitate your reproduction. It's not much of a, fairly obvious conclusion. And so those are all located in this essential part of the brain, the hypothalamus. Now, this is something that's a little more complex, so I'll go through it a little bit more carefully. So if you look on the right, this is where Swanson maps perfectly onto Piaget. And I put the Swanson paper in as a optional reading, but if you're interested in the sorts of things that we're covering this class, that's a great paper to hack your way through, even though it's very hard, because you learn a lot about the underlying biology of some of these more complex clinical and developmental theories that we've covered. So basically, what Swanson is pointing out is that at the lowest level, at the highest resolution level of your central nervous system, you have motor output circuits that are enabling you to move, and those are communicating in large part with your spine, but also with lower parts of your brainstem. So those are fundamental movements of the sorts that Piaget would call reflexive. And then the locomotor pattern generator, I think the best way to think about this from an analogical perspective, and actually Alexander Luria used this analogy. He called behavioral patterns kinetic melodies. It's a lovely phrase, because you know how obviously a song is made out of notes, and then the notes combine into phrases, and the phrases combine, say, into passages, and then, well, even more interestingly then, if it's an orchestral piece of music, multiple instruments are playing at the same time, so it sort of extends right into the social domain. But your actions are sort of like that. They're made out of micro routines, and then those are chained together, and those are chained together in higher order abstractions and so on, all the way up to the cortex. And so Swanson points out that the motor system has three sets of inputs. So the cognitive system, that's sort of way up, that's a level of abstraction that's way up in the brain. So the cognitive system is where, you might do a voluntary action. So you look at something, you say, well, I'm going to pick up this piece of paper. And so that's top-down cortical control. And then the state system input to the motor system. The state system is your body monitoring what's going on inside of itself. And the autonomic nervous system is part of the motor output system. And so the state monitoring system takes a careful look, and the hypothalamus does a fair bit of this, takes a careful look at what's going on inside you, and then activates different parts of your digestive and, the gut system fundamentally that you have no conscious control over. And then, obviously, there's sensory system inputs too. So those are the three main inputs into the motor system, and that acts on the environment. And then the motor system has this hierarchical nature that's built from the spine upwards. And so you can think of like the brain as a collection of ever-expanding control systems that allow you to learn and undertake ever more complex motor schemes of action. And one of the things that people think about human beings is that we're very good at thinking, right? But we're not just good at thinking. Like we're crazily adaptable in terms of our motor output. I mean, if you watch the Olympics, and you see human beings can do things that no other animal could even think of doing. I mean, we're completely crazy when it comes to the sorts of things we can do with our body. Like, we're good on ice, we're good in the water, we can ski, people are really good at jumping, they can climb across buildings. Like, people who train themselves can climb like mad. I mean, human beings are unbelievably variable in terms of their motor output. So that's another part of our intelligence that's not just abstract. And so, in part, that's because we have this very well-developed cortical area that enables us to chain ever more complex patterns of behavior together, and also to develop patterns of behavior that are sort of outside instinctual specification. So you imagine with an animal that has a less complex brain, a lot of its behavior is going to be limited to those quasi-instinctual patterns of behavior that are devoted directly towards the solution of basic biological problems. But, you know, we can kind of solve those without too much effort, and then we have all this spare motor capacity left over, and people do the weirdest things with it. You know, and really remarkable, absolutely remarkable things. So that's pretty cool. We're pretty cool that way.